and welcome to the fourth and final week of the MIT App Inventor Crash Course hosted by the App In Club. Thank you all for being here. This week, we're going to be talking about computer vision, but before we begin, I just want to thank everyone who participated in these lessons over the past few weeks. It's been quite an experience for me, and I sincerely hope that you've gained something from these classes as well. Anyway, let's talk about computer vision. Okay, so here's our lesson plan for today. First, we're going to talk about how computers, quote unquote, see. Then we're going to talk about what computer vision is. Next, we'll discuss how computer vision is used. Then we'll talk about the difference between CNNs and RNNs. And finally, as always, we can finish it off with an app building tutorial. All right, so first question, how do computers see? Well, how do humans see? Well, we as humans are able to see the world through the retinas in our eyes, which capture light for the brain to process. And a computer's vision functions in a kind of similar way because it's able to capture the look of an image. However, instead of colors and lines, the computer sees images as a collection of numbers that describe its shade, color, or intensity. And you can just see that in these images down here. Okay, we're seeing color, we're seeing like basic shapes, but the computer just sees it as a bunch of numbers. Okay, so what even is computer vision? Well, computer vision describes a field of computer science that enables computers to interpret images, videos, and other visual inputs. So if you want to think about it in this way, artificial intelligence allows computers to think, while computer vision allows computers to see, observe, and understand. So how does computer vision work? Well, we kind of already discussed this in lessons 1 and 2, but computer vision usually uses machine learning to replicate the function of a human brain. So think about it this way. We, as humans, we are able to easily recognize and identify images because we already have years of life experiences, as well as hundreds of thousands of years of evolutionary experiences. Computers, they don't have that luxury. So they're basically comparable to a newborn baby, who just also happens to have the ability to hold a few hundred gigabytes of data in their heads. Anyway, by feeding a machine learning model a large amount of training data, we are able to have it gradually teach itself to recognize patterns that distinguish one image from another. Okay, so how is computer vision used? Well, it's used in a lot of things. Okay, automated vehicles use it to see cars on the road. Security systems, such as Ring doorbells, use it to detect motion. Traffic cameras use it to catch people running red lights. Image searching uses it to analyze pictures. Medical scans use it to identify cancers. And optical character recognition, or OCR, uses it to find text in videos and images. So yeah, a pretty wide variety of uses. Okay, so like most machine learning models, computer vision uses a neural network. We've already discussed neural networks during the week 2 class, but today we're going to get into the difference between convolutional and recurrent neural networks. So first, convolutional neural networks, or CNNs, these are the ones we talked about in week 2 with the panda analogy. So CNNs break down images into pixels with tags or labels, and then they analyze it piece by piece or layer by layer. It uses 2 inputs to produce a third output, and the first layer of the neural network is going to detect hard edges and basic shapes, and then the subsequent layers will fill out the space with more predictions. CNNs are mostly used for image recognition. Okay, now recurrent neural networks, or RNNs, these are different from CNNs because of their memory. So they're able to relate one element to another. So that means that prior inputs is going to influence current inputs and outputs. And RNNs are usually used for video analysis and natural language processing, where the context and surroundings of each element is important to its meaning. Okay, so now we're just going to watch this video from Google Cloud Vision. And yeah, let's go.
Human vision is amazingly beautiful and
Oh, sorry, I did not share the audio.
Human vision is amazingly beautiful and complex. It all started billions of years ago, where small organisms developed a mutation that made them sensitive to light. Fast forward to today, and there's an abundance of life on the planet, which all have very similar visual systems. They include eyes for capturing light, receptors in the brain for accessing it, and a visual cortex for processing it. Genetically engineered and balanced pieces of a system, which help us do things as simple as appreciating a sunrise. But this is really just the beginning. In the past 30 years, we've made even more strides to extending this amazing visual ability, not just to ourselves, but to machines as well. The first type of photographic camera was invented around 1816, where a small box held a piece of paper coated with silver chloride. When the shutter was open, the silver chloride would darken where it was exposed to light. Now, 200 years later, we have much more advanced versions of the system that can capture photos right into digital form. So we've been able to closely mimic how the human eye can capture light and color. But it's turning out that that was the easy part. Understanding what's in the photo is much more difficult. Consider this picture. My human brain can look at it and immediately know that it's a flower. Our brains are cheating since we've got a couple million years worth of evolutionary context to help immediately understand what this is. But a computer doesn't have that same advantage. To an algorithm, the image looks like this. Just a massive array of integer values, which represent intensities across the color spectrum. There's no context here, just a massive pile of data. It turns out that the context is the crux of getting algorithms to understand image content in the same way that the human brain does. And to make this work, we use an algorithm very similar to how the human brain operates, using machine learning. Machine learning allows us to effectively train the context for a dataset, so that an algorithm can understand what all those numbers in a specific organization actually represent. And what if we have images that are difficult for a human to classify? Can machine learning achieve better accuracy? For example, let's take a look at these images of sheepdogs and mops, where it's pretty hard even for us to differentiate between the two. With the machine learning model, we can take a bunch of images of sheepdogs and mops, and as long as we feed it enough data, it will eventually be able to properly tell the difference between the two. Computer vision is taking on increasingly complex challenges and is seeing accuracy that rivals humans performing the same image recognition task. But like humans, these models aren't perfect. They do sometimes make mistakes. The specific type of neural network that accomplishes this is called a convolutional neural network, or CNN. CNNs work by breaking an image down into smaller groups of pixels called a filter. Each filter is a matrix of pixels, and the network does a series of calculations on these pixels, comparing them against pixels in the specific patterns the network is looking for. In the first layer of a CNN, it is able to detect high-level patterns like rough edges and curves. As the network performs more convolutions, it can begin to identify specific objects like faces and animals. How does a CNN know what to look for, and if its prediction is accurate? This is done through a large amount of labeled training data. When the CNN starts, all of the filter values are randomized. As a result, its initial predictions make little sense. Each time the CNN makes a prediction against labeled data, it uses an error function to compare how close its prediction was to the image's actual label. Based on this error or loss function, the CNN updates its filter values and starts the process again. Ideally, each iteration performs with slightly more accuracy. What if instead of analyzing a single image, we want to analyze a video using machine learning? At its core, a video is just a series of image frames. To analyze a video, we can build on our CNN for image analysis. In still images, we can use CNNs to identify features. But when we move to video, things get more difficult, since the items we're identifying might change over time. Or, more likely, there's context between the video frames that's highly important to labeling. For example, if there's a picture of a half-full cardboard box, we might want to label it packing a box or unpacking a box, depending on the frames before and after it. This is where CNNs come up lacking. They can only take into account spatial features, the visual data in an image, but can't handle temporal or time features, how a frame is related to the one before it. To address this issue, we have to take the output of our CNN and feed it into another model which can handle the temporal nature of our videos. This type of model is called a recurrent neural network, or RNN. While a CNN treats groups of pixels independently, an RNN can retain information about what it's already processed and use that in its decision-making. RNNs can handle many types of input and output data. In this example of classifying videos, we train the RNN by passing it a sequence of frame descriptions, empty box, open box, closing box, and finally a label, packing. As the RNN processes each sequence, it uses a loss or error function to compare its predicted output with the correct label. Then it adjusts the weights and processes the sequence again until it achieves a higher accuracy. The challenge with these approaches to image and video models, however, is that the amount of data we need to truly mimic human vision is incredibly large. If we train our model to recognize this picture of a duck, as long as we're given this one picture with this lighting, color, angle, and shape, we can see that it's a duck. But if you change any of that, or even just rotate the duck, the algorithm might not understand what it is anymore. Now, this is the big picture problem. To get an algorithm to truly understand and recognize image content the way the human brain does, you need to feed it incredibly large amounts of data of millions of objects across thousands of angles, all annotated and properly defined. The problem is so big that if you're a small startup or a company lean on funding, there's just no resources available for you to do that. This is why technologies like Google Cloud Vision and Video can help. Google digests and filters millions of images and videos to train these APIs. We've trained a network to extract all kinds of data from images and video so that your application doesn't have to. With just one REST API request, we're able to access a powerful pre-trained model that gives us all sorts of metadata. Here's how easy it is to call the Cloud Vision API with curl. I'll send this image to the API, and here's the response we get back. Billions of years since the evolution of our sense of sight, we found that computers are on their way to matching human vision, and it's all available as an API. If you'd like to know more about the Cloud Vision and Video APIs, check out their product pages at the links here to see how you can easily add machine learning to your application. Thanks for watching.
Okay, so that's our video for today. Next, we are going to, just give me a second here. Okay.
Human vision is amazing.
Next, we're going to create our app for today. So our challenge is to create a household items scavenger hunt using MIT App Inventor. And this game is going to include 22 common household items. The user is going to be given a random item, and then they're going to have to find it and take a picture of it using the camera component. Then the look extension is going to check the accuracy of the image. The user is going to gain a point every time the look extension recognizes the item. And finally, we will also have a high score feature that uses TinyDB for storage. So I'm going to, first thing I'm going to do is actually post these slides in the chat. Just give me a second. There is the slide there. Okay. And next we are going to, okay, next we are going to import our extension, which is part one. Okay, so you're going to go to this link right over here, and then you're going to download this look extension. Okay, click on the AIX file right here, and then it's going to download to your computer right here. Okay. Then, once you've done that, you are going to go to MIT App Inventor. There you go. Okay, you're going to go to MIT App Inventor. You are going to start a new project and name it Scavenger Hunt. This is going to be your app. Okay. Next, we are going to upload that extension that we just downloaded. So you're going to go down to extension. You're going to click import extension, and then you're going to choose the file that you just downloaded. Import that. Just give it a few minutes, and it will show right up. There you go, or a few seconds actually. There it is. Then you're going to drag and drop this onto this phone in the middle of your screen. And you're going to want to switch this to an image input. Okay, so that's the extension import done. Next thing we're going to do, or the next part, is the app building. So first thing we're going to do is change the alignment of the entire screen to center aligned. And I'm also going to change the background color to something a little more appealing. I'm going to go with somewhat of a blue. Okay. Yeah, I like that. Next, we are going to, just give me a second. Okay. Next, we're going to put a vertical arrangement. This right here. And then we're going to change the background color to none because we want this to be transparent. Sorry about that. Yeah, so we're going to change the background color to none because we want this to be transparent. Then we are going to add a title. Okay, so the title of the game, we're just going to call it Scavenger Hunt. Scavenger Hunt, exclamation mark. Bold it, italicize it, hit 30, and I'm going to change the text color to orange because that pops off of the background. Okay, then we're also going to add a start button. Oh, remember to change this to center align as well. This is going to be a start button. Start. Let's not make that italic. I want the text to be white and I want the background to be orange. Okay, perfect. I like that. And I'm also going to put a horizontal arrangement right here, remembering to change the background color and the alignment. And then I'm going to put the labels for this high score. It's going to be the high score. So high score. And it's going to be set it as 0 for now. I want this to be red. I'm going to change the size a little bigger. And the same thing here. Okay, that looks it. Okay, I'm gonna change this. Okay, all right. This is going to be basically what the user sees when they first open up the app. Okay, next we are going to create what the user is going to see after they click this start button. Okay, so we're going to put another. Actually, before we do that, I'm going to label everything just so I don't get confused later down the line. So this is the title. This is start. This is the high score. Okay, perfect. All right, so we're going to put another vertical arrangement. Once again, changing the alignment and the background color. And then I'm going to put a label. This is going to be find a, and I'm going to change the size of this. I'm going to keep the color as black for now. This is going to be the item that the user is supposed to find. So make this loading. Change the text color to red. And I'm going to up this to 25. That looks good. And bold it. Maybe a little smaller. Okay. Nice. I'm also going to put an image, put a web viewer, and I'm going to put another button. But this button, I am not going to put a text one. So delete that. Okay. All right. Next thing to do is change the size of this image. Okay. I'm going to change the height to 250 pixels. Change the width to 200 pixels. And okay, change this to scrollable. So I can scroll down. Okay. And I'm going to change the rotation angle to 90. All right. This, I'm just going to leave this alone. And now this is the button. Now we're going to do the button. So the height is going to be 50 pixels. The width is also going to be 50 pixels. And I want this button to be a camera icon. So what I'm going to do is go back here. I have provided this in slides, right? You can just click on this link if you want to use the same one I did. You don't have to use the same one. You can just find whatever one you find. But I'm going to save this image, save it to my computer, and I'll come back here. And you're going to select image, upload file, drag this here, and there we go. That's a camera icon. It's our camera button. Okay, so I think this is a good spot for a progress check. So just make sure that you have pretty much everything you see here. Yeah, if you are following along and you have caught up with me, just give me a 1 in the chat, please. Thank you very much. Okay. Oh, the chat is disabled. Okay, hold on. There we go. Can you try again? There we go. Awesome. Anyone else is following? All right, I'm just going to give a few more minutes. Okay. Oh, thank you, Andy. All right. So we're just gonna move on now. Next thing to do, we are going to add the confidence and the bar. So I'm going to put a vertical arrangement, another one. We're going to change here. Okay, great. I'm going to put a horizontal arrangement inside that. Changing everything to transparent. And then I'm going to put 3 labels in here. Okay. This one is going to be item 1. The middle one is going to be confidence. And the last one is going to be bar. Okay. All right. So this is going to be the item. So I'm just going to make this item 1. Blah. This is going to be a certain percentage. So boom. And this we're going to get to later. So first, hold all of this. And that should be good. Okay. So we want to turn this to a bar graph. If you remember this, if you were here during the first week, you would remember how to do this. So first thing you're going to do is delete this text, and then you're going to put a blank space, just like that. Okay. Just a blank space. And then you're going to change the height to fill parent, and then change the background color to red. Okay. So that's going to be your first item. Next, you are just going to copy and paste this 2 times. So this is going to be item 2, and this is going to be item 3. It already renames it for you, so you don't have to change anything about that. And then you're going to change the background color to blue and yellow, just so you have some differences. Okay, so yeah, that's how it's going to look like. Next is the score. Okay, so horizontal arrangement here, center, background. It's going to be 1 label and 2 labels. It's just going to show the current score. So score, and the score is going to be 0 for now. Okay. Send a picture for the camera in the chat. Sure thing. This one. Hello, Alan. Okay, so where was I? All right, score, that's done. And then I'm gonna put a skip button as well. So skip. And I'm gonna change this to white, bold, and orange. It's good. Okay, then I'm gonna go back and label everything just in case I haven't already. Okay, it's good. Missing. Okay, this should be score, and it should be skip. Okay, that's pretty much it. Yeah, I think that's almost it. Almost done. We are just going to add a camera component. It's going to show up right down there. And we're also going to add a TinyDB component. All right. All right. So that's it for the app building part. Next, we're going to get into the coding. But if you're following along, give me a 2 in the chat. Thank you very much. If you're caught up and up to speed with everything. Oh, what happened to so many people here today? Anyway. Wow, there's 21 of you. Has to be at least like a few people. I show the item text. So you mean this part or this part, the top or the bottom? Oh, make it scroll down. That's easy. You just go to the screen and then you're going to scroll down here and then you're going to check off scrollable. The bottom part. Okay, sure thing. All right, I'm just going to make a new one. So basically, you're just going to have a horizontal arrangement, put it into your vertical arrangement, right? Change its background color to none, change its align horizontal to center, and then you're going to put 3 labels. Okay. 1, 2, 3. This you're going to make item 1. This you can just make whatever, make it that, just to show it's the percentage. And this is going to be the bar graph. So you're going to delete everything there, put a blank space, make the height fill parent, and then change the background color to red. And there you go. That's your background. That's your item label. Okay. Does that answer your question? All right, awesome. Okay, I'm just going to move on for now. So first thing we're going to do is create an items list. So this is going to be quite long. You're going to initialize a variable. You're going to call it items list. And it's just going to be a giant list of a lot of items. You remember like 22 items. You don't have to do that many if you don't want to. Just make sure you're using everything that's make sure if you do shorten it, you do use like at least some of the things that are on this list, okay? Because these are the ones that the look extension can recognize for sure, okay? So I actually have it stored over here, so I'm just going to cheat a little bit. Just get it right here. I know this might take a little bit, so what do you guys think? Should we wait? Okay. Okay, I'm just going to what? Yeah. Why don't I shorten it? Because the shorter it is, the higher of a chance there is for it to pick the same thing twice in a row, and that doesn't make a very good game. So the more items you have, the more randomized it is. But you know what? For demonstration purposes, I'm just going to shorten this to 5. All right, how about that? Let's make this 5, just so we all can catch up and move on. All right. So let's just see what it has here. I'm going to do the toilet. I'll make sure these are all lowercase, by the way. Bathtub, clock, what else? Paper towel. And let's do one more. Sunglasses. Okay. Yeah. All right. So that's our items list. Next, we are going to do some of the initializing. So first, when the screen first initializes, we want to set this vertical arrangement to visible and set this vertical arrangement to invisible. So just going to do that. Set visibility to true. And then we're going to set vertical arrangement to visible to false. Okay. We're also going to hide this image. And we are also going to get the high score. Okay, so before we do that, we're going to have to initialize variable high score. And that's just going to be 0. And then you're going to do set global high score to, you're going to use the tiny db, and you're going to get the value for the tag high score. And if the value is not there, we want it to be 0. Okay. And then you're just going to set the high score text to whatever the variable is. All right, and final thing, you're just going to initialize a new variable. This is going to be current item, and it's just going to be a blank. Okay, so that's our initializing. These are variables and stuff like that. Next is the start button. So you're going to go to here. When the start button clicks, we want to hide this vertical arrangement and show this one. So I'm just going to copy and paste this, and I'm going to reverse it. So this is false and this is true. And then I'm also going to, oh, this presentation is not right, but I want this to be hidden as well. So vertical arrangement 3, I want this to be false. Sorry about that, guys. This should say vertical arrangement 3. I'm gonna correct that really quickly. Okay. Yeah, perfect. Okay, all right, and I'm gonna set the variable current item to a random thing, random item from the list, items list, okay? And I am going to set this label here. This is going to turn into item text to the current item. So get current item, and I want this to be all uppercase. So what I'm going to do is just go to this, use this block, and that's just going to convert everything to uppercase. Okay, so that's our start button. Next is the camera. So when the camera button is clicked, is it camera button? When the camera button is clicked, we are going to call the camera component to take a picture. And after the picture is taken, then we want to set the image to the result, the resulting image, right? And then we're going to set the visibility to true. So there we go. And then we are going to call the look extension to classify this image. All right. Can I slow down? Oh, Samuel. Okay, I'll go a little slower, but if you're behind, you can always look at the slides for reference. All right. Okay. Samuel, should I give everyone a little more time to catch up? Am I good to continue? Okay. Yeah, I'll give everyone like a minute or two just to get to this point. All right. These are all like pretty simple stuff, though. You can all pretty much just like copy and paste this. All right. Am I good to continue? Okay. That's been like a minute or two. I'm just gonna keep moving. Okay. So we've called the look extension to classify the image. So after the classifier is done classifying, then we want to set the items to the results, right? And this is the format that it shows its results in. So you can see here, so this is the result, and the result is a list of lists, okay? So we want to get this. We want to get this label that says pen, okay? And that label is within a list inside of a list, and that list is result. So the way we are going to retrieve that is set item 1 to select from list. Select from list. Oh wait, this is the wrong block. Okay, not this one. This one. Okay, sorry. Select from list result, indexed. Index is going to be this index 1. Okay. And this is going to get you this list over here. Okay. And we don't want this whole list. We just want this first piece. So the way we're going to do that is we are going to put another one, select from list. This list is, the result is already a list. And then we're going to select it, select the first item. Does that make sense? Okay. Next, we want to set the confidence. So the confidence is the second thing in the list, right? So what we're going to do is set confidence text. We're going to set it to second thing in the list. However, if you look over here, the confidence is a decimal number, and we don't want that. We want it to be a percentage. Okay, so that we're going to convert that is by multiplying it by 100. And for good measure, just in case the decimal is too long, I'm going to format this as a decimal with 2 places, just so it doesn't get too long. So you cut it off after 2 decimal points. Okay. And then we're going to join that with a percentage symbol. Okay. It's fairly easy, right? And then we are going to set the bar. We're going to set the width to the same thing as the confidence. Okay. So the second thing. So that's just going to be the second thing in the list. All right. And then you're going to multiply by 100. And you're going to set the bar width to that. Okay. Hopefully that's not too hard to follow. And then you're just going to do the same thing really for all the rest of these items. So I'm just going to duplicate this, item 2. And instead of the first thing in the results list, this is the first list in the result list. I want the second one. So I'm just going to make this index, I'm going to change it to 2 instead of 1. And then I'm going to do the same thing here, change this to 2, and do the same thing with the bar width. Actually, change that confidence to confidence 2, change the bar to bar 2, and change this to index to 2 as well. All right, fairly simple. Then I'm going to repeat that for 3. Okay, that should be good. So that's how we are going to get our results, our classification results. If you look over here, this is pretty much what it's going to look like. Okay. Next. Next, we are going to set this vertical arrangement. This, remember, we hid this earlier, so now we want to set it to visible again. So set the visible to true. And now we are going to test if the recognized item is the same as this item that we are trying to find. Okay. So the way we're going to do that is with an if-then statement. If this first item is equal to the current item, then we want to add 1 to the score. Okay, so set score text to score text plus 1. I slow down again. Okay, I'll go a little slower. I'm sorry. I'm sorry if I'm going too fast. All right. But most of this should just be copy and pasting though. All right. Next thing we're going to do is we don't want this to be a skip button anymore. So because if they get the point, then they're not really skipping anything. They're just going to the next item. So we want to change the skip button to a next button. And we're going to do that just by going to here. We're going to set the text instead of skip. It's going to say next. All right. And the last thing we are going to do is if the score is higher than the high score, then we want to update the high score, right? So we're going to use another if then statement. So if current score, so if the current score is should be greater than if this score is greater than the variable high score, then we are going to call tinydb to update the high score. So we're going to call it to store the value, the new high score, right? And we are going, the tag is going to be high score, right? Okay. Are we all good? Am I still going too fast? I'm sorry if I am. Okay. And the final thing we need to do is the skip button. So when the skip button is clicked, we just want to reset everything and we want to pick a new item, right? So we want to, so the way we're going to do that, set the current item to another random thing from the list, item list, right? Then we are going to update the label. So item text, I'm going to change that to current item, right? This is just updating the item you're supposed to like look for. This is going to, next thing we're going to do, we want to hide this again. So we're going to set this to invisible. So that's vertical arrangement 3. Set vertical arrangement 3 to invisible. We want to hide the picture. We want to hide the image. So we're going to set the image visibility to false as well. And finally, we want to change the skip button back into a next button. So I'm going to go here, skip, and skip text is going to change into skip. Okay, and that should be it. That's everything. This is a fairly simple app, right? Fairly short. If you go back to the slides, you will see how the final app is going to look. So look, if you look here, you can see the clock, right? The app is telling you to find a clock. You just take a picture using this camera icon, and then it's going to show up the confidence is going to show up right here. And because the first item is the one with the highest confidence, then you get a point. All right. Same thing goes over here. Okay. And yeah, that's about it. It's really the end, pretty much. Does anyone have any questions? No questions. Okay, awesome. Right, so here's the final code if you need it for reference. And yeah, that's about it. Thank you guys. Thank you everyone who participated. Thank you everyone who followed along and listened to me talk for the past, I don't know, few weeks. Yeah, that's it. Big thanks to App In Club and MIT App Inventor. Make sure to join if you haven't already. Join the Discord and become a member. So yeah, that's it. Tony, do you have anything else you want to say?
I hope everyone now gained like a further understanding in this field of creating apps and AI. I hope everyone can use this to help them with their future endeavors in whether it is app creation or it is like research in AI. But anyways, that's it for the crash course. But we hope you can improve yourself and learn something more. And then in the future, we will obviously have more crash courses and maybe we go to competitions together. So we hope you can participate in those. But anyways, that's it. And we hope you enjoyed and learned something new.
Thank you guys. Have a great weekend.
Yeah, have a great weekend. All right, bye everyone.